Hello and welcome to another free code session. My name is Jason Bach. In this episode, I'm celebrating 10 years of Rocks. Specifically, I'm going to talk about a package that I created in 2015 called Rocks that allows you to do mocking in unit tests. So what is a mock? What is mocking? Essentially, it's the idea that you create a replacement object that you pass into code under test so that you don't have to talk to a database or some third-party service in your unit test. Sometimes that can be difficult to do, and creating a mock can let you focus on the code that you wrote rather than having that dependency live in your test and that it could affect your test in some way, shape, or form. It allows you to have more control of what's going on in that test. In the code that you see here, which is Rock specific, I'll explain what's going on with other examples later on. But here you can see that I have an interface with a method. And down below, the way I get this all set up is I declare an attribute to target that interface type. Rocks then generates an expectations type where I can specify that I expect members to be called, that the parameters to the methods have certain values, and that it will return a specific value if it has a return type. In this case, I'm just specifying that I expect target action to be called. To create an instance of the mock, I call instance on expectations. Now in a real test, you would pass that mock into code, and you'll see that in some examples I show later on. In this case, I'm just going to invoke target action on the mock, and then I call verify on the expectations object. That ensures that all my expectations occurred during the code under test. And if something wasn't called, I would get an exception. So why build Rocks? Why create another mocking library when there's other ones out there that have existed for longer and people have already used many times over, such as MOQ and NSubstitute. I've used those on projects and I've enjoyed using them. So why build another one? The first reason is because I wanted to do something different with the compiler API, or what's also known as Project Roslyn. This is the compilation infrastructure that now builds your C# code, and has done so since C#6. You can build refactorings, code fixes, analyzers, suppressors, interceptors, and source generators with the compiler API. But I wanted to do something different. I wanted to see, could I build a tool or something else that isn't falling under one of those categories? And when I looked at mocking libraries, they typically use an approach to build the mock type at runtime using a library like Castle Dynamic Proxy. You could also use MonoCecil, or you could use System Reflection Emit types to do this. What you do is you build the type using the intermediate language. This is not easy to do. If you miss one opcode or you do something wrong in just one spot, you can do some pretty bad things. It's also hard to debug code that was generated using IL. And so I thought one day, why don't I just generate C# code and then use Project Roslyn to build that at runtime? And then that makes it easier for me to debug the mock code. It makes it easier for me to look at it and see if I did something wrong as the author of Rocks and so on. So that was one reason why I did this. The other reason was I wanted to see if I could pre-generate the mocks rather than having that done dynamically during a test. Now, the first versions of Rocks still did the generation at runtime. I couldn't figure out a way to do that at compile time, but I always had that thought in my head. With C#9, I believe that was the version, a new feature came in called source generators, and that allowed you to build that code at compile time. So that's essentially why I did this, why I built this library. Just to quickly go through the history of Rocks, the first commit I did to the repository was on February 9th, 2015. And this was just setting up some scaffolding, some base types, and so on. The first commit I did where I actually had success, I was able to get a mock up and running in a test, was 4 days later. If I scroll down a little bit, you can see over here on the right the syntax that I originally had. And if you've ever used MOQ, it may look very similar to you. That's not a coincidence. I used the way MOQ did stuff as a way to set up expectations in rocks. So it looks very similar. But this was the first time I actually got something to work, and it kind of felt nice to have that next step in place. I pushed the first version of the package to NuGet in August of 2015. That was a beta version. The first official version of Rocks was pushed to NuGet at the end of January 2016. As I mentioned before, the first iterations of Rocks generated the C# code at runtime. So it was still acting like MOQ and then substitute, though the code generation was a bit easier, again, to debug and look at what I had done as the author of Rocks to figure out bugs and address them. It made it easier to do that. When C# added the feature called source generators, this now allowed me to do all that code generation at compile time. This has many advantageous features. I'll show you some comparisons to Rocks to MOQ and then substitute in just a moment. But one of the other things it did is it allowed me to inspect the target mock type at compile time and build an API specific for that mock type. You saw in the code example before that I had expectations.methods.targetAction. So that was all generated based on what Rocks saw with the target mock type. So on May 3rd, 2020, I put this issue in to say, we need to change Rocks so that it uses source generators. And as you can see, as I scroll down with this, it took some time and a lot of revisions to get this to work. In fact, I put the issue in March of 2020. December of 2020 is when I finally got this all working. So it was a big chunk of work, but it was the right thing to do. I think having Rocks be a source generator has so many advantages to it, and it makes things so much smoother as well. And I also like that dynamic API creation for each target type. I think that makes the code much more readable and easier to understand what you're doing with your mock. So what makes Rocks different from these other frameworks? Why would I want to pick up Rocks or change my code to use Rocks when I'm already using something like MOQ or nsubstitute? I want to be clear. First, I'm not trying to convince anybody, change everything you're doing in your unit tests. If you got something that works, keep doing that. There's no real reason to change that. Though you may want to, as you see what I'm about to show you. Maybe these things that I'm going to show you address some issues you've run into with these other frameworks. But I want to be clear, I'm not trying to change everybody to start using Rocks. I'm also not putting down those frameworks in any way, shape, or form. There are things that Rocks can do that the other ones can't. But that doesn't mean that they don't provide value. I've used them a lot before in my career, and they work well. But I do want to illustrate that I think by using source generators, using this approach that Rocks does, I think has some advantages that the other frameworks don't provide. The first one is around default interface members. In C#8, the feature was added where you could provide a default implementation for an interface member. In this case, default work will always return to unless you provide a different implementation. In this type, I take an instance of an object that implements that interface, and then I call execute, which will call default work and work, add their two values together, and return the result. So again, if I don't provide an implementation for default work, it will return 2. So how can I write tests for this case? In Rocks, it's simple. Specifically what Rocks does is it says, if you don't provide an implementation for that method, it will just call the interface's implementation. And this isn't done by default in C#. It's a little weird. It's not like you have a virtual method that has an implementation, and if you don't override it, it will just call that base implementation. That's not the way it works with default interface members. So there's a little bit of trickery I have to do underneath the scenes. But as you can see here, I don't provide an implementation for default work, and my assertion says that I should get 5 back, which makes sense. 3 plus 2 is 5. I can override it if I want and provide a different implementation, and then I'll see that my result is 6. With MOQ, it works, but you have to remember to call base. You have to do this extra call to say, what I want you to do is call that default implementation. So you can do this, but I feel it's just a little bit extra work, and you have to make sure to remember to do this. With rocks, you don't have to. If you don't provide an implementation, it just calls that base implementation. With end substitute, I simply couldn't find a way to say, just call the default interface member implementation. I always have to provide this kind of expectation. If I don't, it just doesn't work. So I may be missing something in end substitute, but it doesn't appear to have the capability to do this call the default implementation on an interface if it exists. Access modifiers. If you have a type that has members that are internal or protected, you have to have the permission, for lack of a better term, to be able to see those members. Now, if you have something internal in a library and you want to be able to test that in a test library, you have to put in the following attribute. You have to say internal is visible to my test library. But you may be wondering, why is this first one there? It's because with MOQ and end substitute, you have to allow the generated code that those libraries create to see the internal types in that base library that you're targeting. This is a little weird because Rocks doesn't require this. Rocks, again, is generating the code in the test library. So whatever permissions it has, it will automatically just happen. So it will see those internal members. The other libraries, it doesn't work that way because it's another assembly that's generated. So you have to add this attribute as well. Now you can use things like ifdef and have that disappear for the code that you're going to actually push into a production environment if you don't want this to be there. But it is a little bit of a weird thing that you have to remember to do this. And this did catch me off guard the first time I tried to do something by putting an expectation in with both MOQ and end substitute where that member was internal. Now what happens if I wanted to use an instance of access modifiers in such a way that execute calls internal work calls protected work? I can leave that as is, but maybe I want to provide a different implementation for that. Rocks has no issues doing this. If you have a protected member, as you see down here, well, in this test, I don't provide a specific implementation for it. I don't say I want to do anything different. In this test, though, I changed that method will return 3. And so that you can see here, I now get 3 back. So the point is there's nothing different in terms of what you have to do in Rocks. Contrast that with what you have to do in MOQ. You have to remember that if you want to set a protected member, like I do down here, you have to use this protected call, and then your setup, you have to provide a string to name the member that you're trying to do an expectation on. This is a little fragile. If I change that name, Rocks will just regenerate the code and all is well. With this, I won't catch it until runtime, and so that can be somewhat problematic. It also requires me to know what the return type is. It's not a very friendly way to handle protected members. If it has parameters, I have to use different syntax in Rocks different syntax in MOQ to make that work. So it's overall, it allows you to do it, but it is a little brittle and it is a little fragile. With end substitute, I simply couldn't get it to work. Apparently you have to use reflection to find the member, and then you can do something like returns, but I couldn't get this to work. This will always fail in my tests. So again, I might just be missing something in end substitute, but it appears like it's problematic at best to support calling or it's setting up expectations on protected members. Pointers, something that is very rare to see in C# code. In fact, I don't know if I ever used a pointer in my entire career using C#, and that's been quite a long time. That said, It's a valid thing to do in C#. And you can sometimes see in some packages where interfaces are defined with pointers. In this example, I have a method that takes a parameter that's an int pointer. If I would ever run into this case, again, Rocks handles this just fine. I have my data set up here. I create my expectations. I can then say I expect pointer parameter to be invoked with that pointer. And when I create an instance of that mock, I can just pass that in and everything works as expected. With MOQ and substitute, it's not a good world to be in. With MOQ, this code will compile, but you run it, and at runtime, you'll get an argument exception. With substitute, it's even worse. When I ran this test, and specifically ran this test with this line of code uncommented, I didn't get a pass or fail. It just said, like, effectively nothing happened, which was weird. I went to the terminal and I did .NET test on this project. And what happened was I got a log file. And in that log file, it told me that there was a fatal internal CLR error. Substitute crashes very badly with this scenario of using pointers. Again, pointers are extremely rare in C#, but it is something you can do. And if you would run into it, Rocks handles it like a champ. Ref structs. More specifically, span of T or read-only span of T, which are ref struct types. The span and read-only span types are starting to show up in a lot more places in .NET APIs. And for good reason. It can help reduce memory allocations and make your code potentially a little bit quicker. Having support for ref structs allows you to have support for these types that you're going to see more and more often as .NET evolves into the future. In this interface, I have a method that takes a span of int. And then what I do in this type that uses an I have span instance, it just turns around and calls process when somebody calls execute on that type. Rocks, again, has no issues with this. If I need to set an expectation on process, all I have to do is use the same syntax I've used before. I can specify a return value. I can pass in a span to an object that will pass the span into an instance of my mock. And everything just works. It's all good. With both MOQ and substitute, it won't work. Part of the reason is because MOQ and substitute rely upon something called expression trees. And expression trees allow you to specify a func or an action of T, but it compiles that as an expression. So this is very handy and useful in numerous scenarios in .NET, but unfortunately expression trees have kind of become stagnant. They haven't been updated in quite a while to support new features in C#, and it looks like they will never be updated. It's not going to stay current with new things that are in C#. So for example, when you're doing something with a ref struct, like I am in this test, mock will complain with a compiler error. For example, if I uncomment this code, you'll see that I start getting a red squiggle and I get this error to show up. It just won't work. And again, this isn't span specific. This is a ref struct issue. The same thing occurs with substitute. So if I uncomment this code, you see that I get a compiler error. So I can't even write the code to make this happen. If my target type has constructors that have parameters, I need to be able to pass those in to the mock instance. So in this case, I have a type that has a constructor that takes a GUID and an int. And then in my combine method, I combine the values of the identifier, the number, and then also a virtual method called compute. So I may want to override what compute does and provide a different value in my test. But I still need to pass in those two values to that mock instance. And once again, Rocks handles this with no issues. It's actually type safe. If I hover over instance here, you'll see that it's requiring you to pass in the GUID and the int. Rocks will pass those values into the mock instance, and so those are set and nothing bad happens. MOQ and substitute also support this, but unfortunately the way they do it is through a params object array. So in this case, you can see that I'm passing an identifier and number, and this will all work. But if I switch those two values around, I wouldn't know that I made a mistake until I actually ran my test. With rocks, there's no way to do that. It's expecting those values to be of those types and in that correct order. MOQ and NSubstitute, they don't have a safe way to pass in those constructor parameters with their mocks. Whereas with rocks, it's all safe, it's all type safe, everything works the way you expect it to. And the final one I want to show is with properties that have init or required in their definitions. So in this type, you can see that when I call calculate, I'm going to add init value and required value together and then divide it by the result of a virtual method call, provide denominator, which by default will return 1. An init property means that you have to set it in a constructor or an object initializer. After that, there's no way to change it. So it makes the property immutable and requires you to set it while the object is being created. A required property means that you have to set it in the constructor or the object initializer. Now, if required value had a setter, I can still change it after that. And that just means the only time you can change it is when you're basically creating an instance of a specific type. Required just forces you to do it in the constructor or object initializer. But again, if I had set here, I could change it afterwards. So these two new property features were added later on in C#. And it's kind of important to follow the rules, that you make sure that these are set because, as you see here, I'm expecting those values, those properties to have values that the user set. As you've already heard me say many times, Rocks handles this with no issues. What it does is when the mock is created with instance, all of the instance methods that are generated for every constructor that exists on that mock type, it will put as the first parameter a special generated type called Constructor Properties. Now, if you have other things that need to be passed into the mock, those will show up after this parameter. But what this does is it forces you to set those values when you create an instance of the mock. In this case, init value will be 5 and required value will be 3. So that means that because I've overridden what provide denominator is going to do, then now my result is going to be 4. Unfortunately, with both MOQ and NSubstitute, there's no way to do this. At least I couldn't find a way to say, when I create an instance of the mock, I need to have those properties have these specific values. So as far as I can tell, you simply can't set up your mock correctly with init and or required properties with those frameworks. But Rocks lets you do that. And the last thing I want to show is performance. How does Rocks compare against these other frameworks in terms of speed and memory allocation? I was curious about this as I started to build Rocks and created new versions of Rocks. So I was going to start to build my own benchmark.net tests and compare some of the other frameworks against Rocks. I somehow stumbled across this repository called Benchmark MockNet, where somebody had already done this. So I submitted a PR so I could add Rocks to those tests. And I felt like my results were going to be the worst. Rocks was going to look like the worst out of all of them. I just had that expectation in my head. And surprisingly, the results showed that Rocks was better. And now that I've done things where I've changed it to be source generators, this test suite clearly shows that Rocks is the fastest and consumes the least amount of memory. For example, if I scroll down to something like the test that actually does a verify, but you'll see similar results in all the other tests. This verifies that a method was called. The stub is the baseline that is set up by the author of this repository. It doesn't use any of the mocking frameworks. It just uses a custom type. So that's considered to be the baseline to compare everything against. So all of them are going to be a little bit slower and consume more memory because they have to provide, they have to provide what the mocking framework does, whereas the stub doesn't need to do that. But as you can see here, Rocks, compared to all the other frameworks, is faster. And if you also look at the allocated column, you'll see that Rocks consumes the least amount of memory. Now, you can say, well, yeah, but Rocks is 863 nanoseconds, and something like MOQ is 7,300 or 7,400 nanoseconds, and Substitute is 6,900 nanoseconds. We're talking nanoseconds here. This is something that a human will never see. And sure, the amount of memory is less compared to these other two, but we're talking like 4K and 7K. We're not talking 40 meg. And that's fair. If you're using a mocking framework, even if you have thousands of tests and you're using mocks in all of those tests, you probably won't notice a difference between the two. But that said, it's still something that I, as the author of Rocks, can take some pride in. That I know it will be and is the fastest out of all the ones that currently exist out there. So where is Rocks going to go from here? And I want to be clear. If you're using other frameworks, they work just fine. Even though I showed you some cases where I think Rocks handles things a little bit better, that doesn't mean that the other frameworks don't provide value. They do. People use them all the time. They have millions of downloads. So where do I go from here? Well, I want to be clear. If you're using one of the other mocking frameworks, continue to use it. Even though I just showed that I think there are some things that Rocks can do a little bit better than the other ones, they still provide value. Millions of downloads on NuGet. People use them all the time. So I'm not suggesting that you suddenly switch over to Rocks. Though if you decide to do that, that's fine by me. But they still work. For me, a big value in continually supporting Rocks is that it's a learning experience. As you can see with this list of the number of bugs that I've addressed in Rocks over its history, it's 127. And if you look at any of these in detail, you'll see that sometimes I had to dive deep into what .NET or C# does to make sure that Rocks can handle certain scenarios. And so by doing that, I've learned a lot more than about C# and .NET that I did before. And so I find that to be a valuable experience. With C# and .NET getting a new version every year, sometime in November of the year, that means that Rocks may change. It may have to change to fix a bug or an issue that this new feature brings forth. And now I have to evolve Rocks to handle that. Or a new feature comes in that makes something in Rocks easier to do. I mentioned ref structs. Rocks has been able to support ref structs for quite a long time, but the way it did it is that it generated code for each ref struct type that it ran into. When C# 13, I believe that was the version, added what was called an anti-constraint, you could now say on a type parameter constraint, allows ref struct. This effectively eliminated the need for Rocks to generate any of that code anymore. All I do is I have one type that supports ref struct in a parameter, and that's it. The type is called ref struct argument, and then everything just works. So that improved Rocks just a little bit. It made it so that I didn't have to do as much work to support ref structs anymore. So there may be other features that come up in the future that I can use within Rocks to make the code base a little bit lighter and a little bit easier to manage. As I mentioned before, if you can create a custom derivation of a type and override members in that custom derivation, Rocks should be able to handle that. There's one case, at least one that I know of, that I still don't support in Rocks, and that's something called static abstract members and interfaces. I have an idea on how to make this work, but it's going to be kind of tricky. Specifically, if I have a static abstract member in an interface, and I have two tests that want to provide an expectation for that member, and these tests are running in parallel, how do I differentiate between the two so that the expectations don't collide over each other? I haven't had to worry about that with instances of a mock type because that's specific for one test. If it's static, it can run across the entire unit test library. So I've got to be a little bit careful with how I handle this. So I'm still working on it, but I have some ideas on how to make this work. Rocks also doesn't have as many features as the other mocking frameworks I've mentioned before. One of these features that I've seen is something called ordering, where I can say on an expectation, I expect that one to be done first, and then this expectation is done second, and this one third, and so on. I've been a little bit loath to add new features into Rocks because I feel like having so many features and knobs and bells and whistles in a mocking framework can make your tests actually a little bit more fragile. Do you really care about the order of where these members are being called? You might, but what happens if that order changes with the code that uses that mock? Now you have to change that in your unit test. So again, I've been a little bit hesitant to start adding in new features just to do it, just to say now Rock supports that as well. That said, I will consider it, adding those kinds of features into Rocks if there's value in doing so. What I really want to do is add in these features in kind of a layering opt-in approach. So if I would add ordering to Rocks, my idea would be is that you would provide a value in that attribute definition where you would say, yes, I want ordering in my mock. If you don't want it, it won't be there. And so it won't generate as much code. You don't have as much being done in the mock and so on. But if you want that feature, you could add it. You could add it in by just putting that into that attribute definition. So again, it's something I'm thinking about, and I want to make sure I'm just, again, not adding in features if there's really no good reason to do it. So with that, if you're interested in looking a little bit more deeply into what Rocks can do, you can go to the GitHub repository. That's github.com/jasonbach/rocks. And you can look at all the code there. You can submit an issue if you want to put in a bug when you've been just playing with it and seeing what it can do, and you notice maybe it's not working the way you expect it to. Submit a bug. Also submit a feature. If you want Rocks to do something else, you can always submit the feature, and I'll take a look at it and consider it. And if it's something that I think does provide that value, either I'll do it or maybe you can do it. In the open source world, you can always take PRs. So if you want to go that route, you can do so as well. The package exists on NuGet, so it's really easy to just reference that package and start playing with Rocks to see what it does and how it works. If you haven't subscribed to the channel just yet, please do so. If you've already subscribed, I appreciate you for doing that. Thank you for watching. Leave comments and questions below. See you in the next episode.